All right, this is the coding teacher, and I'm here with my first installment of the 5-minute LeetCode videos, and I'm going to be working on this problem right here. It's add two numbers. It's on a topic that I didn't mention as part of the basic things that you need to study, linked lists. Linked lists do come up in interviews quite a bit, which is why I'm starting with this problem. And the reason why I didn't mention it before is because they're extremely easy to understand. This is what a linked list is. Is essentially I'm doing them in JavaScript because that's like my main language, although at work I do Python and Java. Um, a linked list is essentially an object that has a value, and a pointer to a next node. Um, that's a singly linked list. A doubly linked list would also have a pointer to the previous node. So let's go ahead and get into how we're going to solve this problem. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order. They and each of their nodes contain a single digit. They typically give you this problem without the digits stored in reverse order, right? So I'm gonna go over the explanation of how I would do it if the digits were not stored in reverse order, and that's just reversing them first, right? So let's say that you have linked list 1, and that's the number 123, and then linked list 2 is the number 97. Okay, so how do you add these? First, you got to reverse them. So you make L1 reverse is 3, 2, yeesh, that's ugly. 1, and then L2 reverse is 7, 9. Why do you have to reverse them? So that, when you're adding numbers, it's like 123 plus 97. The tens have to line up with the tens, the ones have to line up with the ones, the tens have to line up with the tens, the hundreds have to line up with the hundreds, right? So if you reverse them, then you're starting off in that way. You're starting off from right to left, and that's how you add numbers. So then what do? We're gonna have some kind of pointer. I'm gonna change color here. So we're gonna have some kind of pointer. Let's call it. What happened, man? L1 PTR. That's gonna point right here, right? And then we're gonna have an. I should probably just not change color. An L2 PTR that's gonna point right here, right? So what are we gonna do? We're gonna build up our result node by node by saying whatever's in L1 PTR plus. So this is our result. Whatever's in L1 PTR plus L2 PTR, right? In this case, 7 plus 3, that's 10, right? So we're going to have to put down a 0 here and then have a carry. So we're also going to have a carry element. And then we move L1 PTR equals L1 PTR dot next. So that one's going to start pointing here. L2 PTR equals L2 PTR dot next. So that one's going to start pointing here, right? So then the next node after that will be 2 plus 9. 11 plus the carry, which we had was 1, 12. So I put a 2 right here, and then my carry is still 1. Then, but let me, delete it and recompute it as 1. And then I finally move L1 PTR right here, and L2 PTR goes to null, right? So I gotta have some kind of way to account for list of different lengths. All right, and what do I do here? 1 plus, and the null I consider it a 0, so and plus the carry, so I have a 2, right? And then 123 plus 97 is 220, so that's my result. Okay, so that's going to be the basic algorithm. You have one result pointer. You're also going to need, so that result pointer stays pointing at the first node, so it never changes. So you're also going to need some result current type of pointer that points here first and then points here. So it points to whichever node you processed last. You're going to need a list 1 pointer, list 2 pointer, and a carry. Okay, and that's a basic algorithm. Just make sure that you cover the cases when there's no node. So the one of these your loop has to iterate so long as one of these is not null, right? And if one of them is null, you have to like have some safety mechanism to consider it a 0. So that's it for the explanation. And let's go ahead and get into some actual coding. All right, so let's start by declaring our variables, right? So let L1 PTR equals L1. Let L2 PTR equals L2. Let result current node. And then we're gonna do while L1 PTR or L2 PTR. And JavaScript just has a nice feature where, you know, if this is null, it considers it false, but in your programming language, you might need to do something like this, right? I think it's a nice feature anyway. Some people disagree. And so what are we going to do here, right? So let's compute the raw value first. So const raw value equals, and here's where I want to handle, what if this guy is null right now and this guy isn't, right? So actually, I'm actually going to write an auxiliary function get value or 0 node, and if there isn't a node, if node is null, or node dot, or there it's something else, right? So I probably shouldn't need this, but I'm gonna put it anyway. Node dot val, and yeah, by the way, we need to notice that this is the interface of the list. So the two properties that it has are val or next, right? If not node or node dot val, or not node dot val, then return 0. Otherwise, I'm gonna return node.val. All right, so raw value is get value or 0. Oh goodness, I just accidentally closed my, trying to use a keyboard shortcut, accidentally closed my browser. So LeetCode, add two numbers. Let's see if it's saved. Yeah. Okay. Yeah, the the shortcut for selecting a term in my IDE is Control W, which is the shortcut for closing a tab in my browser. Anyway, so raw value is 0, and then of L1 PTR plus get raw value is 0 of L2 PTR, and then we gotta declare the carry from beforehand too. That carry equals 0, and okay, so cost actual node value equals raw value mod 10. When we're adding two numbers, we know that it's not possible for the carry to be you know, different from 1 or 0, so it has to be either 1 or 0, but we can still do it this way. It's more generic, right? Actual node value, and then raw value, I forgot to add the carry here. So in here, we got to add whatever carry we have from the previous iteration, right? Actual node value, and then const, or rather, the new carry, right, is going to be, I'm going to use a parse int. You could also use a math.floor, some kind of floor function. So I'm going to change to that actually, of raw value divided by 10. And okay, so now I think I'm ready to start building my list. So the first case that I gotta handle is like I haven't started yet, right? So I have this, actually, let me build my node. So const next node to be appended is new list node with a actual node value, right? And then, so what do I do? So if their result is still empty, so result is still null, I'm gonna say result equals next node to be appended, right? Else, meaning that I've already appended result, then what I gotta do is say basically make result current node dot next equal next node to be appended, right? So whatever node I was looking at, I have to make the next node of it this one that I just created, right? And in any case, I should say result current node dot next, or jeez, result current node equals result current node dot next. So I have to move my result current node forward. Let's see. Will this work? Well, then at the end, after we're done here, handle pending carry, so I don't forget it, right? But let's think this through real quick. We haven't moved the pointers. We haven't moved L1 PTR, L2 PTR yet. So let me just do that real quick because that's relatively easy. So L1 PTR equals, so let's say L1 PTR and L1 PTR dot next. If that's the case, then I'm gonna go there. Otherwise, it's gonna be null. And then careful with copy pasting. L2, 2, 2, 2. So that's how I move my next. And I think result. What if? Okay, so no, what I can do actually is this will be safer. I think next node to be appended. Okay, because that's either, so that'll cover both cases. The case that I had before, I think would break in the beginning. Yeah, when I didn't have, when it was null, when result current node was null, and I have to say, and I try to say result current node dot next equals something, it's gonna throw an exception. Then handle a pending carry, right? So if carry is greater than 0, then we're gonna say result current node. So we know that the lists are not empty, right? So if we went through this, we know that we have a result for sure, and that result current node has a value for sure. Equals new list node of carry, whatever the carry is. And let's see, run code. Let's see if we pass. Wrong answer. Output undefined. Oh, beautiful. Forgot to return. Let's see, wrong code. All right, cool. Let's see if it accepts it. There we go. Yeah, I don't pay much attention to these. I've actually solved problems, in like extremely, in ways that were like almost the same, except for like a couple variable names. And then the results here are widely different. And also, that actually doesn't matter that much. What matters is that your code is legible and understandable. That like big companies care way more about legible and understandable code, at least in my experience. Depends on the team too, though. Depends on what the team is doing. But most teams that are not close to the bare metal, right? So like teams that are building cloud products and that are consuming the products of the teams at a lower level. So like the teams close to the metal are like S3, EC2, and in Google Cloud, whatever team makes the virtual machines and so on. So those teams that are close to that are more infrastructure as a service, they will care more about performance. The teams that build products on top of S3, EC2, and all of that. They'll typically care less about performance and much more about code cleanliness. Okay, so that's it for the solution. I hope that was informative, and I will see you guys next time.